current design practice, the size and shape of the windows are generally based more on aesthetic than functional criteria, in despite of the fact that windows design involves choices that have a great impact on energy consumption and on visual comfort. For such a reason, we will introduce a 5-step method to size the windows at the earliest stages of the design process. The method is based solely on the contribution of diffuse and reflected radiation, so it is strictly applicable to windows not hit by direct radiation, as when they are protected by an efficient sunscreen, and in all cases in which obstructions prevent the entry of direct radiation most of the time. The 5 steps of the method are: first, assess how much natural light the space receives through the calculation of the effective sky angle theta. Second, assess how much lighting the space needs by setting the target mean daylight factor desired, DFM. Third, calculate the windows to wall ratio, WWR, required to achieve the set daylight factor. Fourth, evaluate the dimensional constraints imposed by the target daylight factor chosen in step 2, by calculating the appropriate depth of the space. And finally, fifth, determine the required glass area. First of all, the effective sky angle theta of a building can be evaluated by this formula. The following basic geometrical data have to be known. Distance between the center of the glass surface and the top of the building in front of it, y. Depth of the glazed surface with respect to the facade, y first. Height of the glazed surface, 2 times x, and distance from the building in front of the windows, d. In the second step, the target mean daylight factor have been set. Now let's move on the third step, in which the required WWR have to be calculated. The windows to wall ratio corresponds to the ratio between area of the exterior openings and total wall area of the exterior facade. The minimum windows to wall ratio required for a side lit space, taking into account external obstruction, glazing type, and target mean daylight factor, is given by this formula, where sky angle and minimum daylight factor are the parameters evaluated in the previous step, while TVs is the glazing visual transmittance. The fourth step, 3-factor limiting room depth, should be also considered in the light design. The light uniformity, distance at which the uniformity of the lighting levels throughout the space drops. No skyline depth, distance away from the windows at which the skyline is no longer visible. Depth of the daylight area, distance to which meaningful level of daylight extend throughout the space. The mean daylight factor, in fact, becomes a poor representation of the daylight levels in the space under overcast sky conditions in the case of deep rooms, since they have very high daylight levels near the windows and very low value at the rear. Therefore, a maximum room depth has to be established. In this regards, the maximum acceptable depth can be calculated by the following formula, where ρm is the mean surface reflectance weighted on areas. If data are not available, a value equal to 0.5 can be used as first approximation. L is the room width in meters. H is the window's head height in meters. Spaces with depth lower than this limiting depth usually exhibit relative uniform levels of daylighting throughout. The second factor that should be taken into account is the no skyline depth, which is the distance from the windows at which the sky is no longer visible from the inside space. It can be calculated through a simple trigonometric evaluation, knowing the height of the working plane, windows head height, and no skyline angle. The first factor to consider is the depth of the daylight area. Daylight penetration in a space varies linearly with windows head height. The relationship factor varies depending on whether or not a shading device is used. The limiting depth beyond which the natural light is insufficient is equal to 2.5 times the window's head height considering a windows without shading elements, and 2 times the window's head height considering windows with shading elements. The maximum depth for the exploitation of the daylighting is the minimum of the quantities calculated in the previous passages. Finally, in the fifth step, the area of the glazing system A glazing can be evaluated given the room dimensions, the mean surface reflectance, and glazing visual transmittance. Of course, designers should bear clearly in mind the fact that in a more detailed phase of the design, subsequent refinements by means of detailed simulation models are always suggested. Some other suggestions for designer have to be further introduced. The daylight factor depends, for the same size of the windows, by the distance, the type of glass, by the presence of curtains or other protection, and by the position of windows relative to the floor level. Design should be taken into account that first meter from the floor level does not bring an advantage for the purpose of natural lighting. On the contrary, moving the windows to the top, the daylight factor increases. After that, designers should remember that sloped surfaces around windows help to soften glare. These surfaces should be light-colored and provide an intermediate brightness between windows and room surfaces, making an easier transition for the eye and reducing eye fatigue due to the contrast of luminance. Finally, it has to be noted that it is important not to waste glass surface where it cannot bring any benefit. It wastes energy and causes discomfort. Window size and choice of glass are interrelated factors. For this reason, designers have to keep in mind when sizing a window the concept of effective aperture, evaluated as visible transmittance of the windows times windows to wall ratio. A good effective aperture value range from 0.2 and 0.3. For example, in order to obtain the same effect of natural lighting with a corresponding effective area of 0.26, designer can decide to use clear glass characterized by visible transmission of 0.88 and WWR equal to 0.3, or tinted glass with a lower visible transmission coefficient but larger glazed areas. In conclusion, architects should be able to size the windows according to the primary function of providing natural lighting, and then check if the fulfillment of these requirements is consistent with the other important function that windows have.